This is a problem about describing distributions numerically. This is from Chapter 5 of Bach, Bellman, and DeVoe. And the situation, you probably can't read this on YouTube. It's problem 15. They give us a back-to-back stem and leaf display. It's up here, and then I've reproduced it here. We'll see the whole thing in a minute. Of population growth for the Northeast and Midwest states, that's going to be on the left, versus South and West states in the U.S., that's on the right. And all they're asking is producing comparative box plots. And of course, what they really mean by that, produce comparative box plots and then tell something about what that means. Let's make some conclusion. And then I'm also going to go a little further and talk a little bit about mean and standard deviation as opposed to median and interquartile range for this problem. So here's the back-to-back stem and leaf display. And just looking at this, it's pretty obvious that the Northeast Midwestern states have a very different distribution from the Southern and Western states. And it looks like the bulk of the Northeastern Midwestern are in the single digits. Notice that like a 0 here and a 9 would be 9% growth rate. These are all percentage growth rates. Whereas the 3 and the 1 here will be 31. They've segmented up each first digit, each of the tens digits into 2, because otherwise these would have maybe a lot more than we'd want. And it's a little bit more precise to segment them up into, when the digits are 0 to 4, I put them in here. When the digits are 5 through 9, I put them in here. It's a standard technique for a stem and leaf plot. So let's first just look at the setup in a standard way that they like to do in the book, and that I want people to do in my class. And then think about how to use the calculator to do this. I might do a separate video where we do more of it by hand, and then draw some conclusions. Okay, so here's the setup. Here's the W's. Who is the U.S. states? The individual cases are individual states. What is population growth? But I want to emphasize two things. One is these are relative population growth figures. These are percentage growth rates. So a big state, even if it's got a small growth rate, maybe if it's one of these down here, if it happens to be a big state, that could still be adding a lot of actual people. And so it's important that we're comparing percentages, relative growth rates, relative to the existing size of the state, not an absolute growth rate. And it is a growth rate, we're not comparing how big the states are. We're comparing how much they changed. So you could have a small state appear way up here because it grew a lot in percentage. So that's important, and somebody else might be interested in something different. The unit here is just percent, and that's very common for a relative measurement, especially relative change measurement. The when, if you actually look in the book, it tells us 1990 to 2000. It's a comparison of census data from 1990 and census data from 2000. So this is over 10 years. And so that's very important. If you look at these numbers and think, like especially this top one, this happens to be Nevada, 66% growth rate. If you think that's a yearly growth rate, that's just crazy. That would be almost impossible. It's still a huge growth rate for 10 years, but it's very important that this is a 10-year span. The where is the entire country, but segmenting out Northeast, Midwest versus South and West. So that there might be an issue as to how do you decide what the boundaries are. That's something somebody might ask about. The why is we're comparing growth rates for two different parts of the country. We might have some sort of thesis that says one part of the country is growing a lot bigger than the other, and it looks already that that's probably a reasonable thesis. And the how is this is actually from U.S. Census data. Okay. So let's think first before we do anything. We want to compare growth rates for two different parts. Really, the Y I just put up there of the country. Okay. And why are we going to do a box plot? We're doing something else. Maybe that a qualitative analysis of the stem and leaf displays suggest that the two distributions are quite different, and maybe we want to say that more precisely. Okay, so we'd want to get quantitative measures of center and spread, for example, to talk about comparing these two things. And box plots are particularly good for comparisons. Okay, we'll put those side by side eventually. Okay, so show, I'm going to do this on the calculator, and then maybe in another video I'll show if we had to do this by hand, or if we really wanted to understand what the calculator is doing better, we can do it by hand. So on the calculator, I've already put in, if I go to Stat, Edit, I've already put in L1, I put in the growth rates for, I guess I could use my finger, huh? I've put in the growth rates for the left-hand stuff, the Northeast Midwest, and over here on L2, I put in the growth rates for the southern and western states. Okay, so how do we get box plots? It's pretty easy. Go to Stat Plot. Let's go to Plot 1 and make that a box plot of the first one. This is in the book, but we might as well do it. It's on, and then I've gone to down arrow, and then the type, you actually have to go use the right arrow to get to all of these. You can't use the down arrow to get to this. And I want to change it to box plot with the little dots on it, which is box plot with outliers included. And I want that to be a plot of list L1. And the mark choice is fine. Okay. So then I could graph that. Well, it looks kind of dinky. The scale doesn't look very good, although I can at least see it. I could do zoom 9 and see if I can trust it. Okay. Always, always, always do a reality check on that. Go to Window. Okay, 0, basically 0, minus 0.1 to 13.1. And that seems pretty good for the data. The data was going from 1 to 12 here for the Northeast and Midwest. Okay. And that looks pretty good. So we can go back to the graph. There's our box plot. Okay. The median, the Q1, Q3, and here's the ends of the whiskers. And there's no outliers, and that makes sense. There didn't seem to be outliers. If we go back to this display, they're all kind of clumped together. There's not anything. This one's probably going to show up as an outlier, almost certainly. Okay, so we're not done that with that. Let's see. So now go back to Stat Plot. Let's do Plot 2. Turn that one on. Go to the same kind of box plot, and then L2 seems to be the default for that. Okay. All right, so what's wrong here? Well, I zoomed in to focus on this, and of course the distribution on this one is much wider, and so it's not showing the whole thing. So we could do it by hand, or we could try to trust zoom 9. That looks pretty good. And we can do a reality check. We expect one outlier. Well, maybe we don't. Maybe if we go up here, is this an outlier? Well, that's going to be good when we do this by hand to see whether we consider that an outlier or not. Looks like the calculator probably is considering that the end of the whisker and not an outlier. Let's check it with the window. Yeah, it's going from minus 6-ish to about 72. And so indeed, that's the 66 showing up as the outlier, and everything else is on the box and the whiskers. Okay, so now we can start to make some conclusions. We can look at these box plots and say, okay, so the show is really, so far we just made the box plots. And I'm not going to go bother to do it because it's hard on the computer. I would just go ahead and copy carefully the plots onto our paper. Okay. And then I can start to tell. I can look at the box plot and see that the box plots clearly show that the distribution, no, that's not how you spell distribution, that the distribution for the South and West is centered at a higher growth rate and has more spread. If you look at the IQR, remember that's the width, the whole width of the box. It's got a lot more spread. The length of the whiskers is a lot bigger, and has an outlier at 66%. And in the book, they actually tell us which one that is. It's nice to know the individual identity of the outliers, Nevada. And it says Arizona was the 40. And so that's the top of the whisker there. And that's just way, way beyond anything in the Northeast and the Midwest. Okay. We can also, so let's look at what else we could do here. That's pretty much answering the question they had in the book. Let's go to one-var stats. If you go to stat calc, one-var stats, and let's do one-var stats on L1. So the x bar is the mean, and that's 7.1, or 7.2. Let's look at the median. You have to scroll down to get that. The median is 8. Notice those aren't too radically different. Okay, and does that make sense? Well, this distribution is somewhat symmetric. If we go back to the graph, it's not too asymmetric, and there's no outliers. And so if we wanted to use the mean instead of the median as a summary, that would be okay for that distribution. Okay. What about measures of spread? Oops. I think just let me do second entry to get that back. Okay. Measures of spread, the two standard ones are the IQR, the interquartile range. That's 4. That's the width of the box. So that's one way to say, okay, remember what it means is 50% of the values for that that distribution, the one on the left, are between 5 and 9. And then we could also use the standard deviation. The sigma is a slight variation on the standard deviation, which we're not using yet. It's the SX that we want. That's a Greek sigma, by the way. So the SX is their notation for the standard deviation. That's about 3. And we expect that to be a little bit less than the IQR. And remember, we shouldn't be using that if the distribution is really skewed or has a significant number of outliers. But here, it's not a bad measure. Okay, and we'll learn much more about the deep significance of mean and standard deviation later. But here, it's a fairly reasonable thing to do. If you wanted to report those as well as the median and the IQR, those would be good things to report. Now, let's do one-var stats on L2. I do second 2 for L2. Okay, let's go down to the median and stuff first. Okay, so min 1, max 66. Interquartile range is 10 to 23.5 is 13. So half of the data is within a range of 13 between about 10 and about 23 or 24. The median, 15. So that's a good representative middle value for these southern and western states, 15% growth rate. Half of them were bigger than 15, half of them were smaller. Okay, let's look at the other one variable stats. The mean is, it's not dramatically bigger. It's, if you can read that, it's 19, or 18.86, about 19. That is a bit bigger, and that's not surprising because this distribution was skewed. It's visibly skewed to the high side, let's say to the right, although it's really going up in this picture. It's skewed towards the high numbers. We've got this outlier and then this fairly big number, which is almost an outlier. And so this is a bit of a sketchy measure of center for this distribution. It's not ridiculously bad, but probably the median would be better in this case. The standard deviation, 12.5, it's not ridiculous, but again, that's going to be highly influenced by these values, especially that one outlier. And so it's not a great trustworthy version of the spread. So this is a classic example where we would not, we'd be probably more happy with median and IQR than with the mean and the standard deviation. Whereas over here, it was more symmetrical, and reporting all 4 numbers is pretty reasonable. Okay, so the show is we can also look at one-var stats, and of course I would really copy those onto the paper and report them carefully, label them carefully as what they are. And then I could go down here and say that for the Northeast Midwest, we can use mean and standard deviation as useful descriptors. But with the southern and western states, we would probably want to avoid mean and standard deviation due to the skewness and outliers. Okay.